Oh, hello, Sarah and Shaw. Welcome.
Hey.
Can you all see all of us okay? Yes, cool. So, first off, I guess we should all introduce ourselves. So, my name is Andrew Schultz. I'm a PhD student at Georgia Tech, and I do conservation technology through teaching a class to about 15 to 20 undergraduate students on how they can use engineering and technology to help wildlife. So, we're working on 8 to 10 different projects, and yeah. So, Shaw.
My name is Shah Selbe. I'm the founder of Conservify, which is a nonprofit technology development lab that works just on conservation technology projects. And kind of the head of Field Kit, which is a product that we're developing around creating low-cost, scientifically relevant environmental sensing, which, we build things like this. So.
Awesome, Sarah.
Hi, everyone. I'm Sarah Beery. I'm a PhD candidate at Caltech, and I am definitely like a computer vision researcher first and a conservationist second. So I'm like constantly getting conservation things wrong. But I do really love the space, and I am trying to learn as much as I can. But I've actually been working on basically just computer vision machine learning applications for conservation for 9 years now. So it's been a long time since undergrad, and I've recently a lot of my like sort of pure computer vision-y PhD work has been working with automating species ID and camera trap data and trying to get that to scale up to sort of anywhere in the world instead of just places in the world where people have well-curated training data sets. But I also been sort of trying to extend some of the research we've done into other data streams. So things like audio or sonar or trying to take better advantage of video when it's available. And yeah, like just really, I really enjoy working with conservationists and finding ways to use domain knowledge to actually improve the machine learning.
Yeah. So, my first question, and I might have Googled this morning, is so could you explain some about machine learning and AI and like what are these things that I think a lot of people have heard of before, but might not know exactly what they are?
Sure. So yeah, at a super high level, really machine learning is just another type of model. So if you consider a model to be something that takes some set of inputs and processes them and gives you an output, then machine learning is just another version of that. So a really simple model is like a linear model, right? You take like if you have like y equals 2x, then your inputs are x and your output is y, right? And you can pretty explicitly generate that for anything. Machine learning models just take much more data and then try to fit massively nonlinear parametric models using that data. And they do that by sort of, we call it learning, but really you just show it an example. It tells you what it thinks it is, you tell it if it's right or wrong, and then it iterates until it gets right more than it gets wrong.
So, is a good example like the what is it on Apple devices? Is it called Faces, right? Where it like you say if that's your face or not. I'm
Yeah, like we're basically like I think Google Photos does the same thing,
Yeah.
where it's actually trying to basically like fine tune their generic re-identification model to work well on your device, but without actually breaking any user privacy restrictions. So the identifications that you're doing aren't going back to the main model; they're staying on device, but it's basically just helping to fine tune like maybe the last layers of a pretty complicated model to understand more about like your specific data set, which is like pictures you take about the people you care about or whatever.
So we got a question in chat. Is there a difference between machine learning and artificial intelligence?
So this is just getting into semantics, and people really have a lot of ideas about what these definitions are. I usually go with artificial intelligence is like a concept or like a goal. And machine learning, people like to say that machine learning is intelligence in some way, but it's really just a really big parametric model. It's not actually like generating new intelligence in any like systematic way. And, you know, obviously people try to argue that back and forth. But yeah, really, I wouldn't say that machine learning is quite artificial intelligence yet. Like we don't have the Terminator, for example.
And you work on cameras or images, right? That's your...
Yeah, so I work in computer vision, which all that really means is the input data I frequently work with is an image and some sort of label on that image. But actually, to some extent, like these days, a lot of what works for images also works for other types of data. So the actual underlying like machine learning architectures that we use are not necessarily so different between like if you're working with images or working with text or working with audio.
So like with your data sets, right, for a lot of these, aren't they like several thousand images that you need to actually like iterate through and train, or how does some of that work?
It really depends on the goal, right? And how hard it is. So for example, I can take a pretty good pre-trained model that I trained up on a really well-established detection data set like COCO, and I can take, if all I want to do is learn to find rubber duckies, I can take like 3 or like 5 images of rubber duckies, draw boxes around the duck, and fine-tune something that's actually pretty good at finding only rubber duckies. Now, the reason for that is that rubber duckies are pretty like noticeable, like pretty distinct. And the like, so sort of like the space of potential outputs is like pretty small. And then also, I'm not asking it to like distinguish between things. I'm only asking it to find rubber duckies. Whereas like if I'm trying to get a model to be able to accurately find like really rare animal species in the jungle, like that gets a lot more complicated because those animals might be like really well camouflaged
And yeah.
hard for people to find. My best rule of thumb is like if it's easy for a human, it's probably not going to take that much training data to train a machine learning model to do it. But if it starts getting tricky for a human to do it, then that's where you start having to be pretty clever about how you curate your data and actually like what architectures you choose to use.
So Shah, Tom, and I talked about this 2 weeks ago, but I'm curious. So what does like tech for wildlife, conservation technology, like what do those terms mean to you?
Yeah, sure. I mean, this is like probably a silly answer, but when I hear conservation technology, I just assume it means like taking advances in technology and using them to forward conservation outcomes. And that's pretty general, but I kind of think that a lot of things fall under that umbrella, and I'm happy for it to be a big umbrella.
Mm-hmm. Yeah, I agree.
How did you get involved in this space? Like, how did you get into the community?
Do you want like the really long convoluted story?
Sure. Whatever story you want to say.
Sure. So really probably what got me into this community is I have an uncle who's a zoologist. And when I was really young, he spent a lot of time with me in his basement showing me tons of creepy crawly herps under heat lamps, and they were fascinating. And my other uncles and my dad spent a lot of time teaching me like how to survive in the forest. You know, they're very like blue collar Washington State kind of guys. So they were like very into like, oh, you need to know what's edible and you need to know how to build a shelter. And I loved that. I feel like super privileged to have had that much of an outdoor upbringing. But it meant that I always had a really like strong connection to and strong respect for like biodiversity and naturalism in general. And then I took like a hard pivot. My mother was a dancer and I got into dance, and I really like just fell in love with it and pursued it single-mindedly. And left high school pretty young and danced professionally until I was 22. And thought that I was going to stay in the arts forever because I do really love the arts and I love like sort of how creative it was. And I probably, now this is where it gets like a bit convoluted, but I probably would not have ended up in technology if it wasn't for the fact that they pay artists so badly. So I was dancing for the Atlanta Ballet, and I was like, 17, 18 maybe, and I was really poor and really hungry all the time. And I lived in like a neighborhood that a lot of students at Georgia Tech lived in, and I basically just figured out that Georgia Tech had these seminars where there was free food if you listened to a talk. And so I started going and getting free food, and as a result had to listen to all these science talks. And it was kind of the first time that anyone had told me what you could do with technology. I'd been really focused on the arts, and I had never really had anyone in my life who told me like really what technology or engineering or computer science was. So I thought it was all like trains and factories and maybe video games.
Yeah, that's what everyone. Yeah.
Yeah, exactly.
Do you work on it? Do you work? Yeah. Do you work on a railroad? When I tell people I'm an engineer, yeah.
Yeah, but I started, listening to these talks and seeing all these really amazing, sort of like applications, like things that you could do that really made an impact on things that I cared about, like climate change and sustainability and conservation. And that was kind of like the switch for me. So when I decided to retire from ballet and go back to school, I knew from the beginning that I wanted to learn to be a technologist so I could apply it to sustainability and conservation.
Yeah, we have. What do you think are the areas where AI has the greatest impact? That's a super general question. I'm not sure. So maybe think on that one. I don't. Yeah.
I was actually just thinking maybe we should talk a little bit first about why you're doing camera stuff.
Oh yeah.
Right. So like for anybody who's watching that doesn't know much about like what are some of the tools in conservation technologies, this is one of them. This is camera trap. And I actually think I held this up last time I was here, but the camera traps are used to document biodiversity in places when people aren't there, right? So they strap them to things and they take a bunch of pictures. And then right now, the way that most researchers deal with that data is they sit in front of a computer and they sort through it manually, right? I mean, it's a very kind of tedious process, especially if you have a camera trap that was deployed somewhere where there was a branch that was blowing in the wind, right? And you have 1,500 photos of a branch moving. And so that's what your work is looking at doing, is trying to figure out how to understand that data in a way that doesn't involve a whole lot of hours of some poor person sitting behind a computer staring at stuff, right?
And Shaw, will you talk about like what a camera trap does, like kind of what the like how it works?
Yeah, I mean, so most camera traps are broken down into just a couple different things. You have batteries that go inside of it. You have a camera, and then some sort of like flash usually on there. And the last is a PIR sensor, which is basically like a motion sensor. And so camera traps see something pass in front of that motion sensor and they trigger the camera to take a picture or video. And different manufacturers have advantages in the video or the photo or the triggering mechanism or the lens that they use for all that stuff. Like some are better than others and people have their preferences. These things are not made for conservation. They're made for hunters. They're made for land managers, people who want to have these sorts of things, and conservationists use this. So last time when we were talking about conservation technology, I called this like an opportunistic conservation technology. So it's a tool that already existed, and conservationists have since taken it, and it's become absolutely fundamental in ecology to understand things visually, right?
Yeah, and they're usually right. So just so Chad knows, like they're usually put in high volume areas so something like if you've seen Lion King, like the watering hole, right? So you would think of putting a camera trap to target the watering hole, so you would see a lot of animal activity for like an ecologist that's trying to see what type of animals or how many animals and stuff like that are in the area. So it was a really good point.
Yeah, or actually to some extent, I've learned a lot about camera traps recently because I went to Kenya this January with 100 camera traps. I kind of decided that I didn't have any street cred, and I needed to like actually like get my hands dirty and like really take a camera trap project from, you know, funding to collecting data to analyzing data. And so one of the things that we were doing with that project is I wanted to sort of, I know that machine learning is not perfect. And I think that there's a big gap in understanding from machine learning practitioners who build these models that try to automate these systems, like automate species identification or counting, or automate like, you know, like saying the sex of the animal or the age, or whether or not it has a disease. Like, there are going to be mistakes that the machine learning model makes. And those mistakes are probably going to be specifically biased in some way. And that's just because data is biased. And to some extent, machine learning models like are very good at picking up biases in the data and then propagating those. And it's literally, it's not possible to remove every bias because we don't know what all the biases are. So you have to understand that there's probably going to be some bias in your results. And I realized there's a big disconnect between like the results that I give an ecologist, and then if they take them and they start doing different types of analysis, like say they want to do like a species distribution model, or they want to take individual IDs and come up with a population census. The systematic biases in my results will cause systematic errors in their model. And some errors are worse than others. And I think that, you know, people like me and people who are trying to do some of this automating need to have a better understanding of like what these biases are actually like doing. Like if I, for example, have a model that just constantly underpredicts a species, and then someone takes that model, they run analysis on it, they decide that that species doesn't exist in an area, and then they like set science policy based on that, then like that's not something I'm comfortable with. So I feel like I need to have a much better understanding of like really how the models are being used to make sure that I can communicate correctly with the practitioners as to like what quality control they need to do, or, you know, I can try to change the model to reduce some of the biases.
Which is, I mean, that's a really important point too, because like how things get communicated out is, you know, sometimes some of that study is done and like maybe the conclusion is not correct, but like sometimes that one headline gets picked up by, you know, magazines and stuff, and it becomes like the new normal around like, this is what's in this area, or it doesn't exist in this area. And, you know, governments are setting policy over it. Funders are changing funding mechanisms as a result of it. It's like, it could be big if you get it wrong.
That's been a big thing with elephants, right? Is if an elephant herd like moves over a country line between two countries, it's like, oh, elephants are extinct now. They're all leaving country X and they're going to all the surrounding countries. This place doesn't support elephants. And yeah, I think that's actually a really common thing that I've seen in working in that space. So what so kind of going back to Shell's point, so when you look at these camera traps, so like why do we need to use computer vision, and like why do we care about sifting through these images? Like what do we use? Like, could you talk some about re-identification and some of these sort of things in terms of like machine learning and whatever you want to talk about, Sarah?
Sure. So, like I said, or maybe I should just like really put a disclaimer. I am not trained as an ecologist, so if I get this totally wrong, like please forgive me. But I'm trying to learn.
Yeah.
So there's a lot of different things that people use camera traps for. So probably one of the most common things that people use camera traps for is to try to build these like distribution models for different types of species. And in that case, instead of actually putting a camera maybe at a watering hole, what they'll do is they'll like take a random grid over an area, and they try to really like guarantee some form of randomness within the camera placement. And then they use different statistical models to try to determine like where within a region different types, or one type of species or multiple species in a joint species distribution model, where they exist. And so that's like one outcome. And that's pretty important, especially if you're talking about some of these like long-term studies, because people can start looking at, okay, before we used to see this species living in this entire area, and then a factory moved in here and that changed, right? So it's a really nice way to have consistent monitoring in an area. But people also, with re-identification, so with species distribution modeling, there's a few things maybe you might need. You might need, like, for the species you care about, you might need to know, for example, how many of each of that species were seen, like, over time. But you don't necessarily care about what individuals they were. You just need to know, like, okay, we saw a herd of 30 deer at this GPS point on this day. Whereas if you're actually trying to use camera traps to do like a visual capture recapture, then you need to be able to re-identify the individual. And some people do that by just still physically putting a tag, but then just identifying the tag in the image. And then there's some species where it's actually been shown you can pretty accurately re-identify the animal just based on biometrics. So that's things like zebra stripes. So for the cameras we put out in Kenya, one of the things we're doing in partnership with WildMe, and like they have just their different wild books for different species sets. We're trying to look at the trade-off in performance in visual re-identification of grevy zebras, from camera trap data to like community science data. And then there's a lot of other things people use camera traps for as well. So I work some with people who work on islands, and they have camera traps out that they're trying to catch images of invasive rodents, so they can try to eradicate those invasive rodents as soon as they appear. And in those cases, they're really only looking for one species, but they're specifically looking for the thing that doesn't belong there. So it's actually a pretty hard machine learning problem. It's something you're trying to recognize, something that you hopefully have very little training data for. Other things like look at maybe the spread of disease. If you see that disease starts to spread in an area, then people will explicitly look in camera trap data and try to capture examples of see that propagation of disease over time. So it's a lot of different stuff.
And some projects, even though there's like ethical things around this, are looking for people in places where people aren't supposed to be, right? So there are some poaching based camera trap projects.
Or not even just poaching, but just like human wildlife conflict mitigation.
Sure. Yep.
And I think like the poaching, the invasives, and the human wildlife conflict, those are the use cases where like the closer to real time you can get, the better.
Yeah.
That's where, like, really for it to be useful, you almost need a system that's connected to the edge. And there's similar use cases with like audio sensors, things like detecting logging from like hearing a chainsaw. Like you really want that to be somehow sent from the camera, from this audio, like the static monitoring sensor. You need it to tell you right away that they've seen something that's really out of place.
That's actually a super good point. That right now the way most camera trap data is brought back is someone walking out to that camera, swapping SD cards or bringing the camera back, and then taking all that data off of the device that way. Like there are some connected camera traps. There's some that operate off of cellular or satellite or all different mechanisms, but they're expensive and they're kind of rare in conservation, right?
And because you have to have a cell tower for a lot of those, right? And so the other part that I'm more used to from maybe like the animals that I've worked with and pandas especially, is what they're looking at with re-identification of pandas is doing so. Like in the United States, we're about to go through the census. And so in figuring out, so if anyone has ever gone to like IUCN and seen like how many, you see there's this many pandas in the wild, well, somebody has to actually go and do a study. I believe the last one yesterday Lynn talked about, it was done in 2017 in Kenya for elephants, but they're doing another one in China, I think, for 2021 to see how many pandas are in the wild. And so if you think of a camera trap, you have a panda walk past it and you're like, cool, that's one panda. And then 5 minutes later, you have another panda walk past it and you have to figure out if that's the same panda or that's a different panda. And so when we're talking about re-identification, it's literally like how many pandas are you actually seeing, or are you just watching one that's walking in a circle? So that's really cool. But yeah, that was a big issue when I did some field work last year. we were looking at the cellular tower ones, and it was really awkward because there would be a place that like where it would work really well where no animals went. And so it would be like, oh, it's a great clearing. There's nothing here. There's no interference. Then you put it there. It was there for 2 weeks and literally saw nothing except like you were talking about like a branch going in the wind. And so it filled up really quickly, right? It was not even able to export the data well enough. So there's definitely, I think, some challenges with doing it in, I guess, real time.
Yeah, and I think actually this is somewhere where machine learning can really play a role if we do it carefully, because one of the problems with sending these identifications of this data is like if you have to send whole images, that's really large, and it gets really expensive really quickly if you're sending it over, cell network, for example. So one thing that would be pretty awesome is if we could
Boundary
actually
boxes. Sorry.
I mean, I guess.
Yeah.
No, but just even more high level than that. Just like if on the device itself you have the processing power to run a machine learning model that can identify the species, and if you see a species of interest, it can, for one, it could tell you whether that thing was a waving branch and whether you needed to send it or not. But also, if you see a species of interest, potentially you could just send the species, like just I saw an elephant, or if it's doing re-identification, I saw Elephant Joe. Now that's awesome. Part of the problem is just like to get like the machine learning models that work best tend to be bigger. It's hard to fit them onto the device. And then, like I said before, like nobody should trust machine learning. Like nobody should just take it without a grain of salt. And so I still think we actually need to save all the data that's captured. You can send your real-time IDs or whatever as you want. But you need to save everything, and you need to take that back, and you need to run it through your bigger, more accurate model. You need to compare those, and then you need to do some human quality control as well and compare that. And that just like that sort of, quality and assurance step just has to be a part of the loop. Like I get so nervous when people talk about just like we don't need to do any, we don't need to look at the data anymore because machine learning is just going to fix all our problems.
I feel like that's a big problem in science in general, is not just in machine learning, but in this aspect of biology, behavior, these sort of things, is repeatability. So if all three of us do the exact same experiment in the exact same place with the exact same tools, are we all going to get the same results? And I think that's become, I mean, not to get like too in the weeds here, but right, like now if you submit papers or things like that for publication, a lot of them require you also submit your data. So people can actually, so a lot of literature, if you're reading science, right, a lot of it is peer reviewed. And so now they're actually going through processes where people are reviewing data because there have been so many issues with manipulate. I mean, I remember in one class we talked about how a behavioralist that was working on spiders in Africa, I think, basically took column 2 and copied it on 4 columns. So he got statistical significant data. And so then they asked him for the data, and literally like column 4 was like equals column 3, column 5 was equals column 3. And I mean, the repeatability aspect is not always there in science.
Yeah, well, and okay, that's like super bad actor situation. But actually, I think in conservation, more often than not, it's just that it can be kind of hard to do these IDs, and people don't always agree. And so there's a lot of, I mean, even just within the experts, there's a lot of like ways that people try to guarantee that the labels that they give these species or these individuals are correct. But even that, like, they're just, people make mistakes. And if you're trying to like re-identify a snow leopard based on its spot pattern, like it's possible that you'll just make a mistake. Maybe the snow leopard's kind of wet, or maybe the image is kind of blurry, and it makes it even harder. And then like you have to start making these decisions about like when is something identifiable or not. And there's a lot of gray area there. And so I just think that, I'm a huge believer in open source data. And on the machine learning side, I also think it's super important to open source your data, open source your models, open source your code, and make sure that it's very, very easy for anyone who wants to like run your model on your data, like recalibrate your results,
Standing ovation. Sorry, Shah, were you going to say something?
I was just also going to add that, a lot of times conservation is a field that's not known for just massive amounts of data, so getting out there and collecting this sort of information is like it could be quite hard, it could be expensive, and so the data sets that you're working with are not typically, they're generally smaller than what you would like to work with, right? And so there's issues around that as well.
Well, one thing, and I guess this what areas do you think AI has? One of the things I think is so cool about machine learning, and it has definitely conservation ties, is not just identification of individuals, but identification of behaviors. So this is, I think, one of the coolest parts is it's you were talking about, the gray area, but this is a big issue, right? Is for humans, sometimes you have to be trained for years to be able to understand if a gorilla play versus gorillas fighting, what is the difference between those two things? But if you look at an expert and he gives you 10,000 photos of gorillas playing versus 10,000 photos of gorillas fighting, exaggeration, of course, but like that is one of the things that's exciting for me, because that is, I would say, a field that almost always has less data than even conservation, because behavior data is just ones and zeros. It's okay, I'm going to look after 5 minutes and the elephant's foraging or the elephant's sleeping, and it's just like a 1 or 0. So that's something that makes me really excited about it in this space. So.
Yeah. So I work a lot with, so my lab at Caltech is probably like half computer vision people and half neuroscientists. And those neuroscientists, a lot of them are really interested in animal behavior. And so there's a lot of work that other people in my lab do on trying to just, even in a lab setting where it's very controlled, take videos of Drosophila or mice and characterize their behaviors, and then like be able to do that in an automated way, over long periods of time, because, neuroscientists who are trying to study the effects of a drug or some sort of stimuli on behavior, they need to, it's really tedious for them to then watch these videos and go through and label it, right? So that's this huge need. But what ends up happening is, like, you get two neuroscientists in a room who are both mouse experts, and they do not agree on what is fighting and what is mating and what is playing. Like, these labels are ones and zeros, but they're ambiguous ones. And
yeah. And that's and so what you have to do with a lot of behavioral studies, I'm not actually kidding, is so it'll be like the three of us all go into the field, we're watching the same gorilla, and then we have this ethogram, right, where we're documenting all the behaviors, and then at the end of the day, we compare, and if we're not, I think it's technically 95 or 98% overlapping, then you have to throw that data set out. So it's like and maybe it's only two people, but that's kind of how you're supposed to normalize right now, is just by the people that are sampling but we're talking about conservation, not behavior. So I'll get off my.
I think behavior is probably part of conservation. Like I said, I have a very, very broad definition. But we have the same, you see the same sorts of things with re-identification of individuals, or even with just species ID. So species ID maybe less so, possibly just because there's just so much data to sift through that it's hard to guarantee that at least two people have looked at all of it. But with re-ID, like my very first research project was re-identifying snow leopards, like automatically from data that I got from Panthera. And Panthera, like, they get 5 people in a room, and they all sit down and they like argue it out until they agree. And it's like, you have to get like consensus to agree that this individual is an individual. And sometimes it's just not possible, and then they just don't use that data point.
Yep. It becomes other. So if it's actually funny, if you look at any ethogram, there's always a basically, we don't know what it was category, or we couldn't. Yeah. 5 people are arguing in a room about what it was. So when you're looking at doing something like the identification of snow, so how hard is it to actually make the model for something like that?
Usually, like the animal re-identification models are like, there's maybe some interest in like making them more like high tech, but to some extent, a lot of what people tend to use for re-identification is like pretty old school computer vision. Things like just feature matching that are like maybe not necessarily like deep learning in the same sense. And there's a few reasons for that. So deep learning is good at things that have when it has a lot of examples. So you need a lot of training data for each of your classes. And then you also need a lot of variability of that training data.
Sarah, what's a class? Sorry, you need a lot of training data for your class.
Is one of these like output labels that you might want to give, like an image or an audio clip. So, so one example of a class might be like, take this. Here is an image, and I want to tell you that in this image there is an elephant. Like that, the class for this image is elephant. Or you can do detection, where you say the class for this, like, or here is an object, and I say that that object is an elephant. But also an example of a class might be like, this is Bob the snow leopard. But the problem with that is that snow leopards are elusive and rare. So for most of the snow leopards that we know exist, you might have 10 images. And then there's, a few thousand snow leopards. So all of a sudden we're in this low data regime where machine learning models, like deep learning models, just tend not to work very well. Mm-hmm. And so that's why I think it's sort of more robust to sort of rely on some of these pre-deep learning methods, things that worked really well when you don't have a lot of variability, you don't have a lot of training data. And another good point is that machine learning is very bad at open set categorization. So that's where like I have training data that covers these 10 classes. And so it's like I have 10 species of animal, for example, that I'm trying to predict. And then I see an image that has a species of animal that's not included in my training data. You have no guarantees. Your machine learning model can do whatever. And there are a lot of people trying to solve that problem, but like dealing with training machine learning models with very few examples just doesn't really work that well. And also training machine learning models to be able to understand when something is not one of the things it's been trained to recognize is also just doesn't really work very well. And so in these cases where you're trying to do re-identification of individuals, like there's constantly more animals being born. You're constantly going to have new individuals. You have
and
to
animals develop, right? So you see an animal 1 year and then 3 years, and it might have grown 5 times the size. Yeah, age is a factor. I'm curious with some of these and this, Shah. So with camera traps, do we have the capability to see things that are exceptionally small? So we're talking about these big megafauna. So when we think of, so if I wanted to look at South Georgian in the U.S. amphibians, right? Do we have? Yeah.
I mean, the commercial camera traps are not optimized for that. They're optimized for like wide field of view. Let's
things
try
people
and
are going to hunt.
Yeah, hunting things, right?
Yeah.
It's megafauna, it's things like that. There are people who have developed like, custom camera traps, and there's always projects about custom camera traps. And now that like edge stuff is really exciting, like everybody wants to have like a AI camera trap. That's like a thing that a lot of people are working on, which is cool. What I really want to talk to Sarah about what her thoughts are in that space. But yeah, I mean, I've only seen custom ones. Like, we have a project in southern Cameroon, and there's a researcher there that has developed camera traps for pollinators. So it's just focused on a small flower, and they're trying to capture pollination activity. Now, with something like that, the triggering is like incredibly important. So they just haven't been able to crack that. And so what they do instead is just record until the battery dies and then like put in new batteries, sort of a thing, and then someone has to go and watch that entire, 17-hour recording to try and see when the pollinators came in.
Yeah.
But yeah, there's lots of cool research projects around it. There's not necessarily a commercial, you can't go to Amazon and buy a pollinator camera trap.
So I think that this is one of the reasons I'm excited to talk to Shah is that like, I think an open source version of this where it's supported and it's very clear and easy, like to figure out how to adapt it for your specific conservation use case, like that's what we need. Because like sure, all the mammalogists are thrilled that they just got lucky that hunters also care about big mammals, and then like this commercial product got developed that you can buy for less than $100 and it works pretty well. But if you care about anything that isn't hunters, that hunters don't care about, then you're kind of SOL. And there's so many important things to monitor that are not large mammals, or birds is another one. There's a lot of birds.
Yeah, especially, but and
So.
they're all different. And I think the other one that we talked about was like tracking colors, I think is what we talked about 2 weeks ago, that they're not always super designed for that.
The other thing too is there's marine biologists use camera traps as well. They call them BRUVs, which is baited remote underwater vehicle, or baited remote underwater video. And I was in Belize and we deployed a bunch of these things, and they're typically just, made out of rebar, and then they stick like a GoPro or something on it, and it has a little bait trap, and they see what comes through. And there's some projects that have connected, put like flow meters and other, try and put other sensors on there to get an idea of where that plume of the bait is going, so that anything that they see come to it, they can have a more accurate population assessment as a result of that. But I don't know if anybody, have you ever worked with underwater stuff? You do mostly photos, is that correct? Not video?
Yeah. Well, so I've definitely looked at underwater stuff before. I have a project going right now that's looking at counting salmon at escapement in sonar. So
cool.
One of the reasons that they're using sonar is because, well, like in a really turbid river where you're trying to count salmon, millions of salmon going upstream in Alaska, like RGB is not going to help you at all. You can't see anything. But I think actually underwater is very interesting for that reason. It's like sort of a significantly different domain, and also depending on like what type of water and where you are and what you're trying to look at, like the sensor you need is different, and there's just not going to be a commercial version of every single one of those, because there just really isn't like maybe a market for it. But that's where, I don't know, I feel like everything's moving this way anyway, but the more that we can have conservationists learn to be technologists so that they have the skills to like build the tools they need, but also we have technologists like Shah who, well, he's a conservationist, but like who are making that easier. Like we'll meet in the middle somewhere and everyone will be able to build the sensors they need for their projects, but it's going to take some time and a lot of work on a lot of people's part.
And a lot of collaboration.
We're trying to do it.
Yeah. And that's, totally. I think, the important part. And that's what we talked about so much last week with Tom, and then 2 weeks ago, Sean Thomas, is just this space right now. It's not new, but it's new enough. What we have to do is have conversations like this where you have a computer scientist and an engineer and a biologist in a room, and all of them, instead of having, 5 snow leopard ecologists all yelling about behavior, like 3 people working together to try and design a project that is field ready, and it would work well in the field. It works well for conservation technology. And so like Flame said, to create custom tech for the specific use case. So with creating that custom tech, I'm gonna kind of echo what Shah asked is, so Sarah, what are your thoughts on building a AI camera trap, or like this?
So again, I think to some extent it's like you have to understand that the model will need to be small. Now this is like somewhat temporary. Like now there's like edge TPUs, right? So we're scaling up our capacity at the edge. We're making much larger computational power be much smaller and take less battery. Like it's maybe only a matter of time. But I think the biggest thing that needs to be pointed out is that I think you're much more likely to be able to build a model that can accurately do what you want it to do on the edge if you restrict what you're asking it to do. So I don't really believe that we can build a machine learning model that can predict all the species in the world and then put that on an edge-based camera. I really think that, from my perspective, the way that we're going to get edge-based systems to work is going to be kind of like custom models to go with your custom hardware, right? And that that takes someone on your team, like understanding data, understanding machine learning. You don't have to be an expert in it, but you have to be able to be comfortable enough to build the data set you need to train the model, train it up, put it on the edge, test it, and iterate. And to some extent, like me as a machine learning researcher, like I can only build custom models for so many people, right? So this is where I'm like, I really feel like the more that I can like empower conservationists to like not be afraid of it and like ask questions, but really like take responsibility for their own models, the better. Just because I think like some of it's scalable, like the architecture is probably pretty scalable. We can find good architectures that are pretty robust. A lot of them already exist. Just things like off the shelf, like ResNet 50 that is pretty small and works pretty well on the edge, or YOLO or SSD. But it's gonna take the person who cares about underwater octopus detection, like spending some time finding the right way to bootstrap together like labels and a data set that they can train to be really good at literally just detecting octopi. And then that model will probably work pretty well on the edge. And it will especially work if you train it for the location that you plan to put the sensor, because this variability question is really where we see a lot of performance drop off for machine learning. And it's actually not that hard to train a machine learning model to do really well for like looking at one scene. If all it has to do is find stuff in that scene, it can learn to memorize that scene like so easily. Where it's going to fail is then if you like decide to put the camera somewhere else and you don't think about that, you don't adapt your model to take
so how
people think about AI in these sorts of like it could do anything, right? It's just like you stick it in and it's like yeah, but it's not. It's a lot simpler than that, right? More difficult, I would say. Yeah.
It's the kale salad of technology. Everyone. Sorry, that was absolutely terrible. But yeah, so I wonder, so when you say like move environments, do you mean like would it be okay if I just say I have 4 trees in an area and I moved from tree 1 to tree 2? Is that going to be fine? Is it an issue if I'm like I'm in a rainforest? Okay, now I'm going to go put it in a tropic tundra. Like what is the level of
Okay, so there's a lot of things to kind of unpack here. So there's a few different things that you have to take into account when you're training a machine, like especially like a machine learning model. Like let's just talk about detecting species. So one thing you have to take into account is, say you're building a training data set. Like what species do you expect to see at that location? And what do you want to be able to categorize? Okay, so you need to make sure that all of those species that you want to be able to identify, you have a reasonable amount of training data for. And the best case scenario is that you have a reasonable amount of training data for those species at that camera location. So for example, if you take a machine learning model and you take one camera, just like one camera trap, and you collect data for a month, and you cross your fingers and hope that all the species you might see at that camera have been included in that month of data and that you've hopefully seen them a reasonable number of times, then you label all that data, you train a model on that. Okay, so now you have a machine learning model that's specifically built for one location. That means it's not just that it has memorized like this area and this set of species, it's also memorized like there is a tree in this corner. There are likely to be squirrels that go along the bottom of the path. There is a bird that likes to sit here. So it's really just very, very tuned to this specific space. Now, if you just bump that camera, your performance is going to get worse. Yeah. Because all of a sudden the tree is not where it expected to see the tree, right? So like you can see degradation in a lot of ways, but a simple way is just like, I have camera traps that a big animal hits, and then like I can look at the performance before and after. And if it's not a very generalizable model, like it's going to do worse after the camera. Yeah. And actually, machine learning models tend to do worse on bumped cameras no matter what, just because it's like shifting the prior that like the horizon is somewhat horizontal. Like there's all these confounding factors that machine learning models will like learn to cling to that if you break them, it just messes them up. But then there's this other thing, which is like this regional generalization. So if it's going to get messed up if you bump it a little bit, of course it's also going to do worse if you just take it and move it to the next tree. But to some extent, in the same glade, you have the same distribution, expected distribution of species. So that's like if there's a bobcat that lives there and you see a lot of bobcats all the time, your machine learning model will learn like, oh, it's probably pretty likely that I'm going to see bobcats, and it'll be more likely to predict bobcat. But then if you move this to a different glade where a bobcat doesn't live, even if it's in the exact same region, that distribution of species will be different, and your machine learning model will do worse. And then the scenery is different, so the machine learning model is going to do worse. And then if you take this model and you trained it on this set of species that you see in this forest, and you take it to the desert, well, now you don't even have maybe any of the same species. And then I don't even know what you're expecting the model to do. Right? It will give you a lot of incorrect answers. But really, if you're moving to a whole new region, there's almost no hope. You really have to collect a whole new set of training data. Because you don't know, you haven't taught it the species that it's going to see in that region.
What's the timeline? What's the timeline of how long, how long does it need to be there in order to kind of get accustomed?
So this is where it gets interesting. So from an edge-based perspective, it's better, your model will do better if you let it kind of memorize some of the stuff about a specific area. If you let it memorize that there's a tree right here, it's actually that's helping the model for that location. And if you never plan to move the camera, that's actually good. But if you want to get that model as quickly as possible, your best case scenario is probably leveraging as much diversity of data to pre-train your model. And so now this is where you train a machine learning model. You get these big, robust models, like the mega detector that we published at Microsoft, where it's trained on as much camera trap data as we can get our hands on. And we're asking it to do something pretty easy. And so all we want it to do is find animals, humans, and vehicles. As a result, that model is really good at finding stuff no matter where you put it, right? But it can't give you species IDs, and it's a big model. And so there's these really sort of crafty ways that you can try to bootstrap together different pieces of the puzzle to get models that work well on a new space with minimal labeling or minimal weighting. So you can take your model, right? You take your camera, you put out your camera where you expect to collect data, leave it for a week, take all the data you get in that week, run it through the mega detector to give it bounding box labels and sort out any empty images, because it's pretty good at that. Now you go through all the images that are not empty and you label them with species. And then you take the mega detector and you fine tune that detector on this new bounding box labeled species data for your specific location. And then you see if it works. And it might work pretty well already. And maybe you need another week of training data. But that's this is where the quality control comes in. People always want me to give them specific numbers. So how many images do I need? And it's going to depend actually on your use case and how hard the species are in that area, and how similar that is to stuff that has been seen by some of these larger models. And
do you have to test it on data that's not in the training data set? Is that biasing it in a weird way if you do that?
Yeah, for sure. So
and could you talk about those biases? So when you were talking about that before, someone in chat asked what is an example of a bias that could pop up?
So there's lots. So one example of a bias is this sort of the species distribution bias that I talked about before. So if you have, for example, a lot of training data, you're training on a camera and there's a bobcat that lives there, and so it's walking back and forth all the time. You have tons of images of bobcats. You are training your model to expect to see bobcats at that location. It's actually not a bad thing for that location, because that location, you should use that bias. It's actually useful for that camera location. But if you take that model and use it somewhere else, it's going to guess every single domestic cat is a bobcat, because it's just learned that bobcats are more likely. And there's actually some clever ways you can adjust this species bias, this distribution bias. Like there's some cool work that's come up recently out of my lab and other places as well, where people actually use the GPS location and they train these like global species priors using like iNaturalist data or data from GBIF that are sort of learning like this like very weak, sort of washy, like hugely joint species distribution prior, but you can just then multiply that prior by the output of your model to sort of like shift the distribution to something that's more likely to be where you are. Now, nobody's claiming that those are accurate species distribution models, and maybe using an accurate species distribution model would be a better way to do that. But you do see a big boost in your performance. And actually, if I take a new camera and I pretend that I have an oracle who can tell me like what species will you see here and like what's their distribution, and I use that prior to shift the class priors, you get like 10-15% performance improvement sometimes, just because every single camera has a different biased idea of what the distribution over the species should be, and they all kind of are like micro habitats or whatever.
So if you have, I think you said you brought like 100 camera traps when you went to Africa. So are you able, and this is for both of y'all, are you able to make these camera traps communicate with each other? Like what type of communication, like could you have them communicating in some sense? That was kind of a question of what can you use, was it LoRa for communication between camera traps? Is that possible? Is that something that could help with some of these things?
So I don't know about like actually like device to device communication, but one of the ways that you try to overcome, like for example, the bias that you see at one camera location is if you use like as many camera locations as possible from your region to train. And then you're hoping that you're learning something that is less biased. But so actually my argument with that recently is like, okay, great. Like, yeah, we want to train on as diverse data as possible because we want our model to be pretty robust. But to some extent, like for each individual camera, these biases exist and they're actually useful. And so now I'm a little bit more pushing towards, we actually just want to train models that are like machine learning models that are better able to represent and use the biases that any given camera has. So one of the models we've trained recently that we've seen like really exciting results for, at least in data from Snapshot Serengeti and from the Caltech camera traps data set, is a model that does detection but actually gets sort of context from up to a month at a time. So it builds a representation of sort of a given camera that it gets to use before it does predictions. And I think that's really the way to go with some of these static sensors. It's just like any static sensor, the environment is going to have biases. It's the same with audio. There's like a static sort of background signal that is going to be there at that static camera. Like that bias is going to be there. And the species bias in particular is there no matter what type of sensor you have. So I'm like, okay, well, let's try to build models that can actually learn to take advantage of those biases to do better at a given static signal. That static sensor.
Yeah, and so I think I misinterpreted the person in chat's question, but the reason I asked it in that way is so one of the things that we're looking at is we talked some earlier about negative human-wildlife interactions, and so if you're able to, so for those of you that were here yesterday, we talked about elephant crop rating, but with elephants going in and raiding, obviously there's not only one entrance to a farm. So could you have a way for a camera trap or something along those lines to go, hey, male bull elephant is coming, let's do some sort of response. So as an example, you see an elephant coming towards the fence, right? I'm going to make something up. You release a Febreze scent that is very off-putting, like bee alarm pheromones. But then a lion comes up and a lion is not going to charge the fence. It might jump over it. So is there a way to kind of have that sort of, I guess, communication? And then, right, you would not want that on a single camera trap. You might want that on 15 surrounding a farm. So that's something I'm just curious about is kind of the communication network between a lot of these things.
So, I mean, you also have to ask, is the camera the right sensor for that application, right? So, cameras are from a sensing standpoint, they're computationally and power expensive, right? And so there's a lot you can do outside of that if those are the sorts of answers that you're trying to answer.
Well, and the reason is so the technology, and just like camera traps and these sort of things, right, is that some of what we're looking at is reapplied army sensors that were used for troop tracking. And so there's things that you can do, like instead of using cameras, you can use seismic sensors, because obviously elephants, infrasound and these different sort of things. And so I was just curious about the kind of communication network between them. But apparently the question was meaning connection to the central server to have close to real-time data in places with no network connection. So I think they were asking it in reference to when I said there's no, sometimes there's the issue of not having any SIM cards.
Yeah, there's a couple things about that, right? One is, the amount of data a camera trap collects is big. It's a lot of data, right? So the only ways that you're going to be able to send that is using networks that are kind of used to sending that sort of data. So they do it over, as I said before, cellular or satellite or Wi-Fi, if you can have a Wi-Fi network or something nearby. Things like LoRa can't do that. I mean, you can send a photo over LoRa, like a single photo, but you're abusing the bandwidth, and it's like going to take you quite a long time to do it. It's just not the right technology for it. One thing you can do, though, is if you did have something running, like an edge sort of system running on a camera trap, you could send those notifications over LoRa. You can say, hey, I saw a person with 90%, certainty or whatever, right? Like you could do those sorts of things over LoRa. We've worked on some projects at my organization around sending that sort of data through LoRa. But yeah, it's I think it's hard to use those sorts of things for that. So telemetry, but not actually image data.
Yeah, I'm pretty convinced that the right, like, I just, at this point, I'm not sure that that some of these analyses like need to happen in real time. So I think one question is sort of like, what needs to happen in real time and what doesn't? Because things that need to happen in real time versus things that you can sort of like go and maybe have like a monthly data dump and then do like really thorough analysis with these like big images, like that's great. You should do that instead of spending a bunch of money and a bunch of bandwidth and maybe not even being able to figure out how to send, a terabyte of images, some really small connection. But there are I think there's a lot of applications that do sort of need that real time aspect. And I think that's where figuring out the right edge-based ML, defining the problems in ways that the machine learning model can be quite accurate. So for example, detecting people is one of them. And one of the reasons for that is that there is a lot of people data that sort of exists and is available and is already labeled to be able to build these like very good, very robust, very generalizable people detection models. And then, okay, so now what you need to do is detect people. And then if you see, a person send a notification, like I actually think that's more of an engineering problem. And it seems very, very possible from the machine learning side.
Yeah, I think too, like, we're talking about a specific technology today, right? But like when you're actually trying to solve these sorts of problems in the real world, you should not be coming into it with a technology in mind. You shouldn't say, I have this cool AI camera trap that I want to put out here to solve this problem. You try and understand what the issue is and solve for that.
Yeah, and that's what the end user that we were, I think, talking about 2 weeks ago is like, what is that? So one of the things that has come up a few times in chat, and I'd like to kind of transition us to, is talking some about how to get involved in this sort of thing. So I know both of you all, or I guess all three of us, have experience in being in the space and being around other people that are in this space. So I guess in terms of, I know a few people have asked like how to get involved in it. So there's a lot of, so actually, if you look at the About Me, there's like 6 organizations, including both Conservify as well as fieldkit.org. And so there's a lot of really great organizations. I myself am kind of housed just at Georgia Tech. So if you are a student at Georgia Tech, you can take my class, but that's kind of the breadth of involvement that I am, because I'm still a PhD student. But I know, Shah, you know a lot more about this. So do you want to speak on it?
How to get involved? I mean,
Yeah.
I think that there's always projects that are looking for people. I think Conservation X Labs and their digital makerspace and wildlabs.net are great, communities of people who are doing these sorts of things and very interested in it. So you can just, and then, Twitter is great. There's lots of people in this space that are on Twitter that are always talking about these sorts of things. I think, broadly, there's a lot of people who have interesting ideas or are working on interesting projects and don't have a lot of resources. So if you're looking to volunteer your time, you can find a lot more options than if you're trying to get a full-time engineering job in this space. But I think just like learning more about it and showing people what's possible is a cool thing. One thing that's adjacent to this that I show a lot of people is the Seek app by iNaturalist. So if you guys haven't played with it yet, it's amazing. It's if you show it to somebody who doesn't know anything about conservation, you just have them download it onto their phone and point it at a butterfly, they just get blown away when it tells you, what that species is. So I use it a lot because it's a tool that I could show people like very easily. Everybody's got a smartphone and they can download it and they get excited about what's happening there.
I think it's one of the best like education tools out there. And also just I'm infinitely proud of Grant Van Horn, who just graduated from my lab, who built that
nice.
model. Yeah, so yeah, he did like sort of all the work previously in our lab with community science and like with iNaturalist and with the Lab of O, and he's actually currently working as a research scientist at the Lab of O, trying to work on audio data, so like birdsong classification and more stuff like that. And
yeah, which that's
good. So I think that there's going to be some progress made in that area.
That's another area where this field of technology and research is really popular, is the acoustic stuff. We haven't talked about it much, but acoustic detection is a big area.
Yeah, I hope our guest next week might, I'm still getting it confirmed, but is doing, I think, some on bioacoustics. It's absolutely fascinating. Yeah.
So one of the things that I've been pushing really hard lately is just like, kind of like what Shah was saying, like you shouldn't just pick a sensor and decide that you're going to use it just because. I actually think to some extent, like really the way we're actually going to be able to at least monitor biodiversity well is going to be a combination of a lot of different types of sensors. And one of the most exciting areas of research is basically figuring out how do you blend together like identifications you get from an audio sensor, which is really good at birds, or it's good underwater, or it's good at vocal species like some types of like monkeys or orangutans, or like things you get from a camera trap, which is maybe worse at birds but much better at species that don't make noise. And then like data you're getting from a satellite that's giving you a bunch of information about like changes, like large scale changes in like vegetation, as well as like community science data, like what are people going out and identifying, and how do you handle the fact that every single one of these sensors has a different like sampling bias, and where people place them is like different weird sampling biases. But I actually think that some of the most exciting sort of large scale research going forward is like, how do you combine data from a camera trap with data from an audio sensor, with data from a satellite, with data from a drone, with data from like community scientists, with people doing eDNA, and how do you take all of those things and turn it into better information? Because just a camera trap alone, you're missing like so much stuff, and just an audio sensor alone, you're missing so much stuff. And yeah, so I think that's really exciting. Mm-hmm. And then also along those lines, just bycatch. Like people go out and they collect a data set for, if I'm really interested in like one species of bird, I'll go out and I'll put out audio sensors and camera traps and do all this stuff and collect all this data. And then I'll go through all my data and I'll find examples of the bird that I care about. And pretty much everything else just like festers on a hard drive. And so the more that we can open up our like data sets, like publish those data sets that are collected, like there's a lot of information in that data. And you spent a lot of time and money and effort collecting that data. And your buddy at the next university over who cares about a different species of bird would love to not have to spend the money to like basically just recollect the same data, but then like focus on a different species. And so I think that's really exciting too, is just like looking at all the bycatch, like all of the images from camera traps from anywhere. Like think about how much information there is about vegetation in the background of all of those camera traps that just nobody has been able to pull out yet because it's just vast amounts of data. And I think that's super cool. Like one day we'll have really good machine learning models where they'll like really share information across projects in a much better way.
Yeah, I mean, I would also say like if you say you have a engineering background, or I mean, regardless of what your background is, right? If you want to get involved in conservation technology stuff, I would say, go to Wild Labs, like try and understand the community a little bit more. And if there's something you're really excited about, so if this conversation today got you excited about edge stuff with camera traps, like I would suggest not to just decide to go off and try and start your own project around that. Like try and see who's doing that sort of work. There's a lot, conservation technology broadly has really embraced open source. And I think it's kind of because like we sort of have to, because we don't have the budgets that a lot of other fields have. And we're trying to solve some really hard problems. So there's open source projects you can contribute to and get involved. And like a lot of, we've brought on people onto our team at Conservify because they were helping us with something before. And we're like, we love working with this person. So let's bring them on full time. So I think there's lots of opportunities for stuff like that.
Yeah. And I think it's like anything, right? It's really important to just educate yourself. So, I mean, part of this is conservation technology is super interdisciplinary. And so, like you said, whatever your field is, I really feel like we have to think about educating ourselves some on just biology in general. And I know, Sarah, you talked about like gaining your chops and going and doing field work. But some of these things are, and even if, so a lot of people always think about field work has to be super far away. I know a ton of people who go do field work over the summer in South Georgia, in the marshes. And like, there's ways to get involved and there's ways to learn. And I think that's the really important part, is learning about the end user. And like you said, this community is super big on Twitter, and everyone's like, I would say like nice and well connected, and you can like send a message to person A and they'll be like, you know what, I don't know anything about that, but here's 3 friends I know that are experts in this space. And so talk to people. And I think it's up and coming where we're doing some more education side of it. I know, Sarah, we've talked about, that's what we talked about last week, was like, how do we, and I'm curious your take on this, Shah, but so how do we teach this to a computer scientist and to a mechanical engineer? Do we need because part of the issue, and I mean, it's an issue in mechanical engineering, but you said, right, you have to get people that are super passionate about the subject, but not a lot of people know about it. So if you're not on these things, like you don't know anything about Conservation X Labs, you don't know anything about Conservify, you don't know anything about any of these resources, Wild Labs, how do we get people interested in it? And then further than that, how do we get people to want to pursue a career in it when everybody else and all their friends and colleagues are going and working for oil and gas? And I think that's that. Yeah.
I mean, I think the people who are going to go work for oil and gas are going to go work for oil and gas, right? It's like for, conservation technology is a place where people who are passionate about this sort of work can thrive, right? Because they're willing to put in the hard work. I mean, I when I first started working on this stuff, It was quite a long time ago, and they're just conservation technology wasn't a phrase that people said. Like tech was used in conservation projects, but it was an afterthought, or they were using existing tools. They weren't really thinking about things the same way we're thinking about them now. And I think now we're in a different sort of place where there are, big flashy things happening that bring more interest to this space, like Microsoft and AI for Earth, or the X Prize does all these. There's like all these things, where people are starting to see that, like, oh, engineers are coming in and they can help the people that are in there that are looking for those sorts of better tools and equipment and technology to find those things. I think it's a thing where you don't necessarily have to have, like, full stack developers and mechanical engineers and stuff that are just only going to school for conservation technology, but it's something where, like, people can go and get a good knowledge, good education in that sort of stuff, and then come in and help in areas where they're not. And areas like conservation technology where those fields aren't usually there. I think it's also really important that, like, when you have a project that you're working on in this space, that it's the right people at the table. So for us personally, when we take on any project, it's with a partner that is, a lab at a university or an NGO, and it's got people on the ground. They're integrated with the community. They work with all the folks that live in these areas where they're being studied. They've been there for a long time. They have a long commitment to those communities and to those places, so that this is not something where we're flying in a bunch of shiny technology and then 6 months later it doesn't work and then we're gone, and nobody ever knows about it. These are like longer standing commitments, and I think through doing things like that, you can build these successful projects out of it. So I think it's important, if you're a mechanical engineer listening to this and you want to get involved, I think it's important that you find that community, you find that group of people who are working on something that you're passionate about, and you contribute your expertise and your skills to solving that problem, but realize that everybody who's in that group has their own important voice. And, you're not going to learn everything about conservation. There's people who've spent decades doing that. So
that totally ties into, like, one of the things that I just try so hard to avoid, which is just like this, like, weird tech saviorism thing where people will, like, so a technologist has a hammer, like, so say I'm like a computer vision researcher, and I'm like, oh, I know how to train computer vision models, and camera traps are images, so I can just, like, ask these conservationists to do a bunch of work for me to, like, curate some data. I'll take it, I'll train up a model, I'll hand it off, I'll be like, I did a good thing, wipe my hands of it, not really ever understand the space, and end up giving them a model that just doesn't actually do what they need it to do. And then, like, sort of write some really splashy article that's like, we've solved biodiversity monitoring. And it's just like, it's like those types of conservation technology projects are just like, they end up taking a bunch of resources. And I've seen, I can't even tell you how many versions of this, like, very splashy article I've seen where, some big company swoops in and they're like, we're going to solve everything with our AI. And then, like, it's like they have someone who works for them who, like, maybe just is doing this as a part-time project, and they don't ever really spend the time and, like, learn the domain and learn the need. And then they build a product that just sort of was, like, minimal effort for them, and therefore, like, doesn't actually really fit the need. I don't know. So I'm a huge believer in just, you have to have, if you're trying to do a conservation technology project, you have to have conservationists on the project, and you have to listen to them, and you have to really actually spend some time with the experts, like, learning what is actually needed. And maybe the answer is not a camera trap, and if you have a camera trap, you should go find a different project that needs a camera trap, right? Like,
there's a certain very famous ocean plastic cleanup project that didn't listen to scientists and failed pretty spectacularly after raising quite a lot of money. And that's not what you want to do.
No.
And this is why, I mean, so with the class I teach, we pair students up with project partners. And that was the first thing that we noticed is when and it ties into both of what y'all said. We had these people that were like, oh yeah, a certain big company, we want to help save the dolphins. And we're like, well, do you know somebody who's like working with dolphins? Like that, because we're just a bunch of engineers. Sure, we'll build something, but is it actually going to help? And they're like, well, that's your job, right? And it's so important to think about that. And it's not, unfortunately, it's not just conservation. It's so common in biology. Hey, so I want to study elephants. Can I come spend 6 months getting all of this data, and then I will never see you again? I will never credit you in anything. And I appreciate getting to spend time on your wildlife reserve and da da da. Da. And it's unfortunately still very common in a lot of these things. Is you'll read a publication and it's like in the very last line of acknowledgments, we thank blank for the 4 months we spent on blank wildlife reserve. And you're like, wait, it's 4 months? Like, so you did all of your data collection here? And yeah, it's
the thing that frustrates me too is, and now that we've moved into the rant section of, is too, when you see like companies that are doing it as a result of like corporate social responsibility. So it's like, oh, we're going to come into this, nature reserve somewhere, and we're going to give like crazy IT technology to the rangers, but their commitment's only for like 2.5 or 3 years. So 3 years later they leave, and those rangers
no one knows. Yeah.
that support. They don't have the funding to be able to continue to run those systems. And that is not a solution. That's like a marketing thing, like
it's very what it's to me is, it's like, this sounds so, it's the joke where you give somebody a car as a gift, but the only thing you do is you give them the down payment. So it's like, hey, cover the down payment.
right.
Here you go. Good luck for the next 4 years on. Yeah. And so it's so common domestically and internationally of this just like you were talking about. And yeah, I guess we're in the rant, we're in the rant portion here in the last few minutes. But yeah, oh yeah, there's so many things to rant about.
So one thing, because I've actually worked a bunch now, I spent time at Microsoft. I still collaborate with Microsoft AI for Earth, and I'm currently working in Google Research, like partnering with Wildlife Insights. Like I've spent time in these companies with these efforts. And what you frequently find from my experience is just like, there are people who really care, right? But in terms of like the large scale scope of the company, like Google might have a ton of money, but really for them, or Microsoft, like for them, like this project it's not ever really going to be about the bottom line of the company.
Sure.
And so there's this very interesting thing where these people who are really passionate, who are working within these companies and trying to redirect some of these resources to really important stuff, but it's so complicated politically within the company. And I've been actually just trying to wrap my head around, like, what are the right partnerships in these ways, like with these big companies that have some sustainability, that have some longevity. And like, to some extent, like no conservation organization should be responsible for like building a data center. Like ideally, we find the right way to have these long-term relationships with large companies where they're providing a lot of very needed resources, and the conservationists are providing the right expertise, and we set it all up in a way so that there is longevity, so that like they're not, the funding's not just going to end, and where nobody has been educated like on the ground, like how to take it forward. And I think that that's something that we really need to think about from our projects, like from the beginning. Like,
yeah, I mean, it's got to be built.
How's it gonna last?
Totally, it has to do capacity building, right? Like you can't just bring in the shiny stuff and then show like how good it all is, and then when management changes or like something changes the company, they pull out. That's the frustrating thing is
So
if it was more of like a longer relationship, creating those sorts of capabilities locally and helping the community deal with those sort of issues, I think that's what we need, right?
Yeah, but also to some extent, I think it's pretty hard. Like, I think that everyone has like their own sort of skill set. One of the conversations I have a lot with my advisor is just, he'll be like, oh, okay, so you're building this model, then like, you know, like how is someone going to use it? And I'm like, well, I'm partnering with Microsoft to help release the model, and they're providing support in terms of like this open source repo, and they're doing some of like the scalability in terms of like batch uploading. And he's like, well, shouldn't you just build it yourself? And I'm like, well, let's look at my skill set. Like, I'm really good at building machine learning models, but I'm also a graduate student. And this is my problems with academic projects, is they either end when the publication gets released, or they end when the graduate student graduates.
Right.
But that's also not sustainable. And so much of this work is happening either through industry or through academic projects. It's like, we need, like, I don't think that I'm the right person to implement, a software package like for a biology team, because I know that I cannot guarantee I can spend the rest of my life supporting it. And so I've been pushing a lot just for like, okay, well, if we're going to set up one of these projects, like, we need to make sure that someone on that biology team has built in funding for software maintenance. Yeah. And there's a software engineer who is part of the project, who is not, a machine learning research grad student, who's actually like just going to do the nuts and bolts. And that funding needs to be built into these projects, these conservation projects from the beginning, to have software engineers.
Yeah, which is like, it's, as someone who like chases funding quite a bit, that's a difficult ask. Some funders are coming around to like understanding the importance in that sort of thing. But for a long time, that kind of funding wasn't really easy to find.
I know. And I actually, that shift in perspective is just going to be so powerful, just in terms of like understanding that just robust, like front end software expertise needs to be a part of any technology tool if it's going to have longevity, right? Like, it just needs to be built in.
Well, and what's amazing to me is I'm gonna keep just harping on the education side, but is how difficult of a sell it was. So I understand the difficult sell for finding funding, because I was looking at finding just basically like resources for the class, just like, and the thing with engineers is they're like, what are you talking about? That's so easy. Like, working with biology is so easy. And we talked about this 2 weeks ago and talked about it last week, but so much of the time people think that, engineers think that, it's just a biological system. It's very, very simplistic. And so when I was doing some of these education proposals of like, hey, so we should get like a TA for this class or something like that to help facilitate new projects. Well, it should be really easy, because like biology is just really simple. And that was like that's what we got from our reviews. For one of them was, this project is too simple. Biology is a very simplistic process for engineers to go through. And
that's wild to me.
It's the same thing of, I know that seems wild, but like my PhD research is focused on elephant trunk biomechanics, and we submit a paper and people are like, why is n equal to 3? Like, I read a mouse paper a few weeks ago and they had 85 mice. Why did you not get 85 elephants? And you're like, is this a real thing? And yeah, it's I'm going back to the complaining, but I think why education is just so important in this space. And I guess my hot take is, and I wish I had done this, but more engineering majors, computer scientists, just getting exposure to biology, because I actually took and I was talking to Sarah about this, like, when was the last time, you took a biology class? And for me, starting doing some of this work, I got all of these behavioral questions, and I'm like, I have not taken biology since freshman year of high school, which was 2009 now. So I was getting questions, and I was like, the last biology class I get was talking about like kingdom, phylum, order, like species, right? Like that. And so I took a behavioral biology class this summer, and it was one of the best experiences of a class I've taken, but I got annihilated because they're like, oh, you don't know about genetics. You don't know about evolution. I'm like, nope. I've literally, the other thing they talked about was the scientific method. Most engineering classes do not go over the scientific method. So what is a hypothesis? So that's actually one of the first things we do in the class is we talk about the scientific method, and people are like, I haven't seen like hypothesis since sophomore year of high school, and they're juniors and seniors about to graduate in mechanical engineering, and what they've been given is they're like, hey, Shaw, take this camera trap and just make it 2 pounds lighter. You don't need a hypothesis for that, right? And that's kind of senior designs, and that's just nuts to me that we don't have some of that education side of just general, and it's not even just animal science, but general science in this. And I think that's why having people on the ground in these positions are so important.
Yeah, but also to some extent, it's really hard to plan degrees, and there's so much like interdisciplinary whatever that like so I think having a conservation technology class is great, and we're hoping to we have this like AI for science class that we run at Caltech. It's a project-based class, and we're hoping to sort of do a spin-off of that that's kind of really just conservation project focused. But one of the problems is just like there's so many possible like interdisciplinary collaborations you can have in medicine and agriculture and like all these different things that I don't know if it's that we need to really like have classes as much as we just need to like encourage people to do projects and find the right partnerships, but also like just educate them in how to do a good project that is well defined, has a possibility of success, and doesn't die on the vine, right? Like, because if they're gonna spend the time and effort, like I think it's just really important to try to give them the possibility to succeed with that, and that's hard.
Yeah, the right tools, and I think this is now what I do a lot of is kind of teaching people about like the pitfalls, and I internally have created my own process around how I think about conservation technology and the questions I need to ask, the things I need to think about, and tomorrow morning I'm teaching a class at UW-Madison about monitoring and evaluation of your projects. And so we're talking about, once you build it and you put it out, how do you improve it? And what do you look for when you're doing that sort of stuff?
You're going to record that class? I want that class.
Oh, yeah.
Well, it's the project management aspect. I mean, it's amazing. You don't get that till senior design a lot. I mean, I was actually, as a graduate student, you do all these, tell undergrads what it's like to be a grad student. And one of them I get the question all the time is like, I'm so upset. My undergrad projects were so bad because there was always people who didn't put the work in. And it's just kind of this sort of thing. And it's like, well, did you manage that? What did you do? And you just don't get any sort of project management. I got it the second semester of my senior year was we had project management conversations in senior design. And it's like, these are things you're going to use in industry. So, yeah.
To some extent, like I think a huge part of learning like the graduate school process, like getting a PhD, just some huge percentage of that is just learning how to manage your own projects, right? Like I wish that they would actually just sit down and teach us a course in that instead of all this theory. I mean, the theory is useful too, but it would have been more useful to have someone just be like, this is how you set up a data set that you don't accidentally overwrite and ruin like 3 months of work, right?
Well, and this is how you make something open source, and this is how you can get a group to all give you input on this. And I mean, that's the nice part about it's weird because Twitter, I actually talk to mechanical engineers about this all the time, and they'll be like, everyone uses LinkedIn. And that's true for mechanical engineers and chemical engineers. And then like no biologists are on LinkedIn at all. Like they're all communicating all their science on Twitter. So it's a bunch of these different things. But we're getting to the end of our time. So the last question that we have that we talk about every week is, what is a book, podcast, basically any form of media? Sarah, if you want to talk about a form of art that is making you excited right now, and that you'd encourage other people to read. I can start. I'll grab my book. Or Shah, you want to start?
I'm actually going to cheat on this one, and I'm going to say that Seek by a Naturalist is my suggestion, just because it's way cooler than any other idea I would have for right now.
I recently I moved to live with my partner during COVID, and so the plants are slightly different here than they were in Pasadena, and I am now an accurate naturalist, and most of the plants that live on the vineyard we live on, thanks to Seek. Like I just go around and California cudweed, like black sage, but it's like I had to. Seek taught me that stuff. Like I have a field guide, but it's much easier to just do with the camera. I freaking love that app.
Yeah, that's cool.
So a book. So I'm part of this this larger scale the Resnick Sustainability Institute at Caltech just got a lot of money to kind of expand from the Resnicks. And one of the things that they're doing is starting these different initiatives. And so I'm on sort of the organizational board of this quantitative ecology initiative. And so as a group, it's like a bunch of professors. I'm there to take notes, but I'm learning a lot. I'm mostly just learning a lot about academic politics, but it's also just been really informative to be sitting in this room with all these professors who are experts on different aspects of ecology research. And we as a group all just read this book called Effective Conservation Science. The tagline is data, not dogma. It was written by a few people, Peter Kariva from, I think he's from UCLA, he might be from USC. But that book was super fun to read and was really informative for me, just specifically about kind of how conservation research traditionally happens, and some of these weird things that happen, a number will come out in some flashy article, and it's actually really hard to trace back where did this number come from, and just sort of some of these best practices for how do we make the conservation field sort of less flashy and more reproducible and sort of more based in actual data. I don't know, I really enjoyed it, and it was a good learning thing for me as a computer scientist who hasn't taken a biology class since 2000. And so, but also on the art side, a lot of ballet companies are releasing old videos that are usually never publicly released, but just you can go Pacific Northwest Ballet has released them doing Balanchine Serenade, for example. And so there's just awesome ballet videos that have been released because of COVID, because none of the ballerinas can perform. And so take advantage if you're into ballet.
My book is math themed this week. I love, that's what I got my undergrad degree in, and so it's probably the nerdiest book ever, but it's Zero, the biography of a dangerous idea, and it's a biography of the number zero. I mean that. It's so cool if you're interested in history at all, which I love, that's what's really, really cool about it, is it actually talks about how, I don't think this is political, but back in the day, the Catholic Church used to do some not so nice things to mathematicians that use zero in their proofs. And it talks about everything from, when zero was first discovered to derivatives and stuff like that. So I got to read that as my break book this week. But Shah, if you want to post your book link in chat, well, I'm going to thank you all so much. So I think this was a great episode. And yeah, thank you, Shah and Sarah.
Great.
Bye.
Yeah. Bye.
Well, everybody, I thought that was a great stream. We had a lot of fun. I think Shah and Sarah are both amazing conservation technologists.
It's fun to talk.
Yeah, no, this is great. This is a lot of fun.
Whoops, sorry, I messed up. But I think this was a ton of fun. There was a lot of really cool things that we discussed. I think talking about AI and machine learning, I know there's a lot of entry level stuff that we did not get to, but I really think we should have her back to talk about more stuff. I know we didn't get to do a deep dive as Bubba and Lieutenant Hobbit, and I know Tugboat, y'all had so many questions about it, but I think there's a ton of things to get involved with in terms of conservation technology, and if you do !guest in the chat, you'll actually be taken to Sarah's webpage. And then if you look below, so if you go to chat and then you look at about, if you scroll down in the about page, there is information about Conservify as well as fieldkit.org. And so you can actually just do the commands for Conservify as well as fieldkit. And that will take you to the websites there that Shah is currently